this network, once again we are going to make use of KCL and KVL, that is Kirchhoff laws, and we can find the current in the various arms of this circuit. We see over here, that is, we have one junction over here where more than two wires they are getting connected, and over here also, so D is another junction where 1, 2 and 3 wires they are meeting. So we have C and D as junctions. So what we do is, first of all we apply KCL, that is Kirchhoff current law, and for that we can start from any junction. Let's say we start from this junction and we say if the current I1 is coming over here, I2 goes over here, so I3 is this way. Obviously, what's the current is going this way? Suppose this is 10 ampere, so if 6 ampere goes over here, 4 ampere will be going in this direction. That is, I1 is equal to I2 plus I3. So first of all we can write the equation for KCL. I1 is equal to I2 plus I3, we get one equation. So over here we see that is we have 3 variables, so we need to have 3 equations so that we are able to find I1, I2 and I3. Now let's apply KVL, that is Kirchhoff voltage law, to various loops. Over here we see that is we have 2 loops. One loop we can make it this, the second loop could be this, and even the third loop that could be a bigger one. We can make equations for these all the 3 loops, or if we are just bothered about finding the answer, we make only the equations which are required to get to the value of I1, I2 and I3. So here for A, B, C, D, A, that is we have A, B, C, D, A. We are starting with A, we have to close the loop at the same point, that is A only. So we go in this direction. Current is flowing in this direction, so over here the current will be flowing in this direction. This is one arm, so in one arm there is only one current and only in one direction. So I1 shall be flowing in this direction. When we are going from here to here across this resistance, then obviously in the direction of conventional current there is a drop, there is a potential drop, there is a potential loss. So we say 2 into I1 is a drop, so because it's a drop, so we write minus 2 into I1. When we go from here to here, from negative to positive we have gone, so we have a benefit of potential, so there is a potential gain 24. From here there is no resistance. When we go over here, that is from positive to negative terminal we are going, that is we are going down the potential, so it is minus 27 volt. We are moving in this direction, the direction of conventional current, there is a drop. So 6 I2 is the difference. We are going in the direction of conventional current, so there is a loss, 6 minus I2, that is minus 6 I2. We reach over here, we come back over here, and we put this whole thing is equal to 0. That is the potential difference between this point and finally between this point, that is equal to 0 only for any loop. We can also take CDFEC, that is CDFEC. We can take any loop. We can start from here also, we can start from here also. This is your discretion. So it starts with this C, it closes at C. C, D, we are moving in this direction. So minus 27, from positive to negative we have gone. So there is a loss, minus 27 volt, minus 6, and current in this arm is I2. So 6 into I2, losses they are in the direction of conventional current, so minus 6 I2. And when we go over here, so I3 current, we see that is coming over here. Current is flowing from higher electric potential to lower electric potential, so it means we are going from lower electric potential to higher electric potential. So we have a gain of potential, so plus 4 I3, and we reach over here. There is no other circuit element, so we reach over here and put it equal to 0. So we can make use of these 3 equations and we can find the value of I1, I2 and I3. At times the students they get confused whether there is a potential gain or there is loss, if it is going to be positive or it is going to be negative. Generally at this level we are going to have mostly only 3 circuit elements. One is we are going to have batteries, the other is resistances, and maximum you can have capacitors. Once you understand batteries and resistances and whether across them there is a potential drop, there is a gain or loss, you can also understand easily about the capacitors also. So first let's take the case of a pure battery. Let's say this is A and this is B. Now we have only 2 ways. Either you will be moving in this direction or you will be moving in this direction. And let's say this is a 5 volt battery. When you are moving from here to here, let's say from negative to positive terminal, your journey is like this. You have taken a loop, and so that you are moving in this direction. So from negative to positive you are going. So this is going to be plus 5 volt. Whereas if you are considered a loop, like suppose you are going from here to here, then it will be a loss. From here to here, from positive to negative you are going, so this is going to be minus 5 volt. So from here the battery's work is done, battery's job is done. Then come resistances, that is when to take it as positive, when to take it as negative. Let's say this is resistance of 10 ohm and the current is 2 ampere, right? And we are moving in a loop from here to here. When we are moving from here to here, then obviously in the direction of conventional current there is a loss. So if we are moving in this direction, we shall be having a loss of 10 into 2. V is equal to IR, that is I is 2 into 10, that is 20 volt drop. So that's why it will be minus 20 volt. We shall write and we shall be writing it as minus 20 volt. But if we are moving from D to C, when we are moving from D to C, so once again when we say that is conventional current is flowing in this directions and the conventional current or positive current flows from a higher electric potential to lower electric potential, so it means this is at higher potential and this is a lower potential. And if we are moving from D to C, it means we are moving from lower potential to higher potential. So we have a gain of what? 2 into 10, that is plus 20 volt. So in the loop, if we are going in this direction, like over here, when we are going in this direction, current is going in this direction. If we are going in this direction, that is against the conventional current, so we have a gain. So it will be 4 into I3 positive. We are getting it as positive. So primarily you will come across, when you are applying KCL and KVL, you are applying Kirchhoff laws, you will come across electrical resistances and batteries and maximum capacitors, as you have done about the, once you understand the potential gain or loss, you can deal with anything, be it batteries, be it capacitor, be it resistances.